All right, here's part 2 of your review video. All right, so number 11, what are the solutions? So you can solve this any way you want. The way I would do it is I would just solve it this way, like we were doing with elimination. Because if you see you have negative x, that cancels. Negative 3y, positive 3y, that cancels. And then 9 minus 9, that cancels. That gives you 0 equals 0. Well, since we get 0 equals 0, what this means is these two equations represent the same line. All right, they represent the same line, which means, since they're the same line, they have infinitely many solutions. So anytime you get 0 equals 0 like this, it means it's the same line, and you have infinitely many solutions. Okay, this one would be dependent. All right, this would be a dependent system. All right, because it is the same line. All right, number 12. So for this one, you can really solve it however you want. Let's multiply the top by 3. So that'd give us negative 3x minus 6y equals 21. And then the other one is 3x plus 6y equals 6. All right, add these together. Cancels. 0 equals 27. Well, 0 does not equal 27. So what this tells us, because this does not make sense, so anytime you're solving these systems and you get something that doesn't make sense, it means they are parallel lines. And remember, parallel lines have no solutions. All right, parallel lines have no solutions because they will never touch, they will never cross, there is nothing that will ever solve them. This, remember, is an inconsistent system. All right, so 0 equals 0, it's the same line, infinitely many. 0 equals number, like in this case, 0 equals 27, obviously it does not, but this is what our system gave us. So it means that it's parallel lines, so it's an inconsistent system, which means there are no solutions. No solutions. No way to solve that. All right, moving on. Number 13. Solve by graphing. In this case, they're already graphed for us, so we just have to figure out which graphs match these equations. All right, so let's look at y-intercepts. We have a y-intercept of -1. We have a y-intercept of -2. Well, this one's gone because these would both be positive. We're still stuck with that one. Okay, so we only ruled out letter B. All right, so y is less than or equal to -3x minus 1. So that means we would shade below that line. And y is greater than 3x minus 2, so we would shade above that line. Well, here, both of these are shaded below, so it's not A. Here, both of these are shaded above, so it's not C. So that means it has to be letter D. Let's verify. All right, -3x, so this has a negative slope, goes through -1. We've shaded below it, that's right. This here has a positive slope, so +3. It goes through -2 and was shaded above it. So we just double verified that D is the correct answer. All right. 14. Funny thing is I can just leave that there because D is also the correct answer for number 14. All right. Let's just verify. So get rid of all that. All right. So let's verify. Y is greater than or equal to 4. Which means we're going to shade above the line y equals 4. Well, here's the line y equals 4. It does appear we're shaded above it, so it could be A. Here's the line y equals 4. We're shaded below it, so nope. Here's the line y equals 4. Again, shaded below it. Nope. Line y equals 4, shaded above it. Yes. So we're down to A and C. Now, y is greater than the absolute value of x minus 1. All right, it's hard to tell here where the vertex of this is. But since we know y is greater than, that means we need to be shaded above it. So our V would be in here something like this. I know this is really terrible. And as you can see, we've shaded below the V, not above the V. So A is gone. And again here is our V. This is really terrible. And as you can see, we are shaded above the V as well as above the line y equals 4. So therefore, D is the correct answer. All right, so for 13 and 14, you just have to make sure you can graph the lines properly and shade properly. Remember, y is greater than, you shade above. Y is less than, you shade below. All right, moving right along. Number 15. Your club is baking vanilla and chocolate cakes for a bake sale. They need at most 27 cakes. So let's let X be the number of vanilla and Y be the number of chocolate. So they need at most 27 cakes. So that means that X plus Y, all right, X plus Y, they need at most, so that would be less than or equal to 27 because we want at most, so we don't want more than 27. All right. Now, next, you cannot have more than 13 chocolate cakes. So Y will have to be less than or equal to 13. And we also know that we have to do more than 0. I mean, we can't have negative amount of cakes, so X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. All right, so there's our constraints. Now, write a system of inequalities to model this. All right, well, here X plus Y, well, they left out the equal to bar, so that one's gone. Let's look at letter C. X is greater or equal to, Y is greater than or equal to, X plus Y, oh, nope, greater than or equal to, so that's not right. I'm going to have to scroll down here a little bit. Let's look at these two. We know it's not A or C, so we can just kind of ignore them altogether. All right. X is greater than or equal to 0. Y is greater than or equal to 0. X plus Y less than or equal to, okay, that one looks good. X is greater than or equal to 0. Y, X, oh, nope, these two don't match. D is out, so B is the winner. Now verify the graph. So we know we're going to have to be above the X, to the left of the Y. X plus Y is less than or equal to 27 if you bring the X across. All right, we subtracted the X from both sides, so Y is less than or equal to 27 minus X. This is that line. We are in fact shaded below it. And Y has to be less than or equal to 13. And this is the line Y equals 13. And yes, in fact, we are shaded below it. So therefore, number 15 is B. All right, number 15 is B. So the important thing for this one is knowing how to set up the equations. All right, we know we wanted at most 27 cakes, so X plus Y has to be less than or equal to 27 because we don't want any more than 27. Then it says you cannot have more than 13 chocolates, so Y is less than or equal to 13 because we can't have any more than 13. And of course, X is greater than or equal to 0, Y is greater than or equal to 0 because you can't have a negative number of cakes. Then all we did was compared what we got to all the equations here. These equations didn't match, these equations didn't match. So we went down here, these equations matched, these didn't. So we went with B, and we also checked our region to make sure everything was shaded properly, and in fact it was. So number 15 is B. All right. Number 16. An exam consists of two parts, section X and section Y. There can be a maximum of 80 questions, which means X plus Y has to be less than or equal to 80 because there's a maximum of 80 questions. If you look, we can roll out A altogether right from the beginning. All right, there must be at least 10 more questions in section Y than in section X. All right, so that means that Y, there has to be at least 10 more, at least is greater than or equal to X plus 10 because Y has to be at least 10 more than X. All right, so that one's good, that one's good, and that one's good. All right, so we still have 3. And then of course, we can't have a negative amount of questions in any of the sections. So we have to throw these 2 in as well. If you're noticing, there's a common theme with these 2. Pretty much every one you do, you'll have these 2. All right, x is greater than or equal to 0, y is greater than or equal to 0. Because if you're dealing with physical objects, you can't have a negative number of the objects. All right, so we've compared to all of our equations, and we could only rule out A. Now we have to match the graph. Well, if we subtract x, we know we have to have a negative slope of 1. Well, if you look, this has a negative slope of 1, a y-intercept of 80. Oh, there we go. And then this has a positive slope of 1, which this side of the graph does have, and a y-intercept of 10, and there it is. All right. And then we're shaded below this line, above this line. We're above the y to the left, above the x to the left of the y. So it appears C is in fact our answer. But let's verify these 2 to make sure they're wrong. All right, well, if we look here, we don't have a y-intercept of 10. Okay, we don't have a y-intercept of 10, so that one's out. And here, we have an x-intercept of 10, but we don't have a y-intercept of 10. So therefore, we ruled that one out as well. So the only possible answer for number 16 is C. All right. Again, we graphed our equations and we checked on the shading. Solved them for y. This one has a slope of -1 and has an intercept of 80. This one has a slope of 1, has an intercept of 10. Shaded above this one, below that one. So there we go. Letter C is the right answer. All right, 17. An after-school program consists of 2 groups, X and Y. In order for the program to run, there must be at least 80 students. So X plus Y, at least 80, greater than or equal to 80. All right, so this is less than or equal to, we can take that out. Less than or equal to, we can take out letter D. So we've narrowed it down to A or B right at the beginning. It says there must be at most 20 less students in section Y. All right, there has to be at most 20 less students in section Y. So Y will have to be less than or equal to X minus 20 because at most there must be 20 less students. All right, so Y has to be less than or equal to X minus 20. And then of course, throw in these because you can't have a negative amount of students. Let's check for this one. Oops, I got to scroll down a little bit to see letter B. As you can see, let me recross out these 2. As you can see, Y is less than or equal to 8x minus 20. This says Y is greater than X minus 20. So B is out, so the only one left is A. So 17 is A. We can check the graph. If we minus X, we know -1 slope of 80. If we follow this line up, yeah, it looks like it could go through 80. And then Y equals X minus 20, so this would have a slope of +1, I'm sorry, and then an intercept of -20. If we follow this down, yep, it looks like it could go through -20, so there we go, letter A. And of course, while the shading here, we would shade above this one, and we would shade below that one, so that just double verifies, or triple verifies, however many times we verified it. All right, so I'm doing so many of these because you need to know how to take an equation and set up your constraints. Remember, these are your constraints. All right, so you need to know how to take an equation or take a word problem and set up constraints to match. All right, let's look at 18. Graph the system of constraints and find the x and y value that maximize the objective function. So we're going to graph x is greater than or equal to 0, y is greater than or equal to 0, y is less than or equal to 1/3 x plus 2, and 4 is less than or equal to y plus x. All right, so first of all, let's go ahead and solve this for a variable. So if we subtract x from both sides, we're going to have y is less than or equal to 4 minus x. for that one. All right. So let's go to our graphing calculator. Let's get a new one. So Control W, no. All right, let's pick a graph. So oh, it's already up there, so we don't have to hit Control G. Let's graph y is greater than or equal to 0. Back to Control G. Let's go ahead and graph x is greater than or equal to 0. Now let's graph our two equations. Control G. Y is less than or equal to. Let's get our fraction bar up. Control divided by 1/3 x. Make sure you put the x beside the fraction. Don't put it in the bottom. So 1/3 x plus 2. Whoops, 2. Enter. And then our other one, Control G. Y is less than or equal to 4 minus x. Bam. All right, so the part where everything overlaps is this part right here. So we need to find all 4 of these vertices. We already know this one is 0, 0. So we need to find this one, menu, analyze graph, intersection, pick this graph, pick this graph. Now, first corner, basically what we're going to do is we're going to draw a box around this point. So first corner, see the little box there? Second corner, so this intersection is 0, -2. All right, let's get some of these equations out of the way. Yeah, put you up there. All right, so now let's find this one here. Menu, analyze graph, intersection, pick one graph, pick the other graph. Lower bound, so we're going to the left. Upper bound, we're going to the right. So 1.25 comma 1.5 comma 2.5. Let's get this one down here. Go back to menu, analyze intersection, pick this one, pick that one. Lower bound, upper bound, 4, 0. And just for the practice, let's do the origin as well. So here, first corner, drag, second corner. So here's our 4 intersection points. Now, what are we going to do with these? The first thing we're going to do, let's go ahead and write them all down. 0, 2, 1.5, 2.5, 4, 0, and of course the origin 0, 0. Let's flip back to our test. So we want to maximize this for the objective function 7x minus 3y. So what we're going to do is we're going to try all 4 points. And if you notice, all 4 of these points are all of the vertices. So that verifies that we did this problem correctly. So we want to maximize the objective function. So we're going to plug these in. Whichever one gives us the largest value is going to be the one we pick. C equals 7 times 1.5 minus 3 times 2.5, and that's going to equal a number. C equals 7 times 0 minus 3 times 2. And C is going to equal 7 times 4 minus 3 times 0. And then C equals 7 times 0 minus 3 times 0. That one's easy. That one's nothing. This one here, that cancels out. 7 times 4 is 28. This one cancels out. -6. So now we just need to do this one. So we're going to do 7 times 1.5. And then to that, we're going to we're going to subtract 3 times 2.5. And we are going to get 3. So we wanted to maximize it. So we looked to see which one of these gave us the biggest answer. If you notice, 28 is the biggest, and that was 0.40. So letter C is the answer because 0.40 gave us the largest value, and we wanted to maximize the function. If we wanted to minimize the function, all right, we don't know what this problem is asking us, but if we wanted to minimize the function, this gives us a -6, so that could be our answer. Or if it's something we're selling or whatnot and we couldn't have a negative number, then we would need to pick 0 as the right answer for the minimum. All right. So it depends on what we were doing with this. But for this one, we maximized, so it's just the 28. All right. Let me clear this off. All right, 19, what is the feasible region? Again, let's go ahead and graph all these. X less than or equal to 0, y less than or equal to 0. And then we have y is less than or equal to negative x plus 5. And y is less than or equal to 1/3 x plus 3. All right, so let's go back to our our calculator. Let's go ahead and control W. Let's clear this out and get a new one. And let's start our graphing. Y is greater than or equal to 0. Control G. X is greater than or equal to 0. Go back to control G. Y is less than or equal to negative x plus 5. And control G for our last one. Y is less than or equal to control divided by 1/3 x plus 3. Enter. So here we go again. Here is our feasible region. We need to find out all of the intersection points. So menu, analyze, intersection, pick here, first corner, second corner. Okay, so 0, 0. Menu, analyze, intersection, here and here. First corner, second corner, so 0, 3. Let's do it again. This graph and this graph, lower and upper. So there we go. And then our last one, here and here, lower and upper. So there's our points. 0, 3, 1.5, 3.5, 0, 0, and 5, 0. And if we flip back to here, all of these 4 answers are the 4 points that we found. So now we're going to plug these into here and see which one gives us the largest value. So cost equals 4 times 5 minus 4 times 0, which is 20. Cost equals 4 times 0 minus 4 times 0, which is nothing. C equals 4 times 0 minus 4 times 3, which is negative 12. And then we have C equals 4 times 1.5 minus 4 times 3.5. Well, this is going to give us a larger number because it's 4 times 3.5. So we know this is going to be a negative number. So therefore, 20 is our largest. So 5, 0 is where our function is maximized. So therefore, 19 is A, because that is where our function is maximized. All right, so again, for 18 and 19, we graphed the constraints, found the intersection points of the feasible region, or found the vertices of the feasible region. We tested all the vertices, and since we were maximizing our functions, we looked for the largest value, and our largest value occurred for number 19 at 5, 0. All right. And let's move on to the last question. Number 20, your surf shop sells 2 types of surfboards. Type A, all right, type A, which we're going to represent with the variable X. They cost $272 to make, and you make a profit of $29 on each. Type B, which we're going to represent with Y, cost $136 to make, and the profit is $17 on each one. You can make no more than 50 surfboards, so we know that X plus Y, no more than, is less than or equal to 50. And you need to make at least $1,210. So we know that, so we're going to use our profit for that. We're going to do 29X plus 17Y. We want to make at least $1,210. And of course, our 2 standbys, X is greater than or equal to 0, Y is greater than or equal to 0. So now we're going to go and we're going to graph these 4 restraints, our constraints. All right. But if you notice, we're missing our objective equation. We have our constraints, but we have no objective equation. So it says you must order at least one of each type of surfboard. So we know we're going to have both types of surfboards. How many of each type should you order if you want to minimize your cost? So this is where we're going to use the cost equation here. All right, so our cost is going to equal 272x, because that's how much it costs to make brand A, plus 136y, because that's how much it costs to make brand B. So this is our objective function, and these are our constraints. And this is OE objective. Sorry, it's objective equation. I call it function, same difference. All right, so next thing we need to do is we need to graph these. So we need to solve these for one variable in preparation to graph it. So if we subtract the x from both sides here, we simply have 50 is less than or equal to, y is less than or equal to 50 minus x. Here we can subtract the 29x minus 29x and divide 17. Divide 17. Now you can just leave this like this if you want to. Y is greater than or equal to 1210 minus 29x over 17, because we can graph this as is. And that's exactly what I plan to do. All right, flip over to the Inspire. Let's go Control W to get a new one. And let's graph our equations. So we have y is less than or equal to 50 minus x. If you notice, it's going to blanket the whole graph. That's because we just graphed something with a y-intercept of 50. So we're going to have to redo our window when we get done. All right, so now let's graph the other one. Control G. Y is greater than or equal to. Now do parentheses, and we can do the 1210 minus the 29x. Close it, and then divide it by the 17. This way, we don't have to worry about messing up the math, because the calculator would take care of the math for us. All right. And then, of course, graph the two standbys. That's what I call these two. I don't know why. I just do. All right. Now let's adjust our window. Go to Menu, Window Zoom, Window Settings. We know we're not going below the x-axis. Let's take this up to about 75, just so we know we get it. We know we're not going to go past the y, and let's do this to 75 as well. And let's see, where do they cross? Oh, well, they cross right here. So we have 3 points we're going to have to find. Okay, you can move this around by grabbing it. So we have 3 points we're going to have to find. So let's go ahead, Menu, Analyze Graph, Intersection. Pick this graph, pick that graph, lower, upper, so there's one. Menu, Analyze Graph, Intersection, pick this one, lower, upper, so there's the other one. And then Menu, Analyze Graph, Intersection, pick this graph, pick that graph, lower, upper. All right, but now, so we have our 3 points, but if you remember from the equation, it said you must order one type of each surfboard. All right, which means neither of our variables can be 0. So we can kind of throw these two out, and we kind of know that the 30/20 is going to be the right answer. But let's go ahead and do the math with all of them, just to make sure that 20/30 is the correct answer. All right, so let's flip over here to our calculator. Now, hopefully you have the objective equation written down, which you should. So we know it's 272 times 30 plus 136 times 20. That gives us 10,880. All right, let's do our other two. 272 times 41.7 plus 136 times 0. That gives us over 11,000. So, okay, let's do our third one. And that gives us 13,000. So, as you can see, just to confirm it, at the point 30/20, our cost is minimized. All right. So if we make 30 type A surfboards, 20 type B surfboards our cost is minimized. So if we go back to here, let's see, 30 of type A, 20 of type B. So therefore, number 20 is B. All right, don't get fooled here because this is also 20 of one type and 30 of another, but this is backwards. All right, remember we put X as type A and Y as type B. So we need to make sure that since X is 30, that's associated with type A, and since Y was 20, that's associated with type B. All right, and again, to solve problems like this, you have to take the word problem, find your constraints and your objective equation, or your objective equation. From there, you go and you graph them. You find your feasible region, which is where everything overlaps. You find the vertices of your feasible region. So in this case, 30, 20, 41.70, and 50, 0. Then you take those points, you plug them into your objective equation. Since we wanted our cost minimized, we found the one that gave us the smallest cost, which was 30, 20, 30 being X, 20 being Y. And again, we associated X with A, so that's 30 of type A. We associated Y with B, so that is 20 of type B. All right. So this has been your part 2 exam review. Feel free to watch this one as many times as well. Make sure when you come to class tomorrow, you are ready to take the exam. See you tomorrow.